Good morning to everyone. Experimental archaeology incorporates a variety of multidisciplinary methods, techniques, analyses, and approaches through an imitative context to approach ancient practices, create and test hypotheses, and provide and enrich analogies that aim to contribute to the archaeological interpretation. Experiments with well-defined variables have been proven to be a powerful methodological tool in archaeological studies. In terms of experimental funerary archaeology and cremation studies, emphasis is given to the understanding of pyrotechnology and the deciphering of the use of fire in manipulating the deceased. Many efforts have been made to reconstruct cremation pyres, emphasizing the different stages of a thermal episode. At the same time, the researchers tried to decode the combustion procedure and record all the observable thermal alterations on the human body due to fire. Human bodies cannot be used in archaeological experiments due to ethical restrictions. However, the researchers always select pigs and other animals with ethical compliance. In archaeology, experiments concerning the burning of the human body were applied by many researchers, mainly in the USA and in Europe. They are classified into two broad categories: the reconstruction of cremation pyres in open-air places, well known as open-type fires, and the implementation of controlled experiments in laboratories using industrial kilns, well known as closed-type fires. In open-pyre experimental cremations carried out to date, researchers have put much emphasis on archaeological questions which involve different aspects of the technology of fire, such as the amount and the type of fuel, the level of technological expertise, and mastery of the ancient communities through the construction of a successful and high-intensity pyre, as well as the recording of the extrinsic factors that affect the final result of a burning event, the calculation of the maximum temperature, and the duration that can be achieved in an open-type pyre, and the documentation of the different stages of burning the human body until its final calcination. Our first attempt at experimental cremations was in 2019 in the framework of a master dissertation project carried out by the first author and supervised by Sevi Triantafylou at the Aristotle University of Thessaloniki in Greece. In this case, two pyres were built in an open area where two pig carcasses were burned at different decomposition levels. One of the main aims of that experiment was to observe how an open-type fire affects the combustion of corpses in various stages of decomposition and to record similarities and differences in the whole procedure. This comparative procedure contributed significantly to studying archaeological burnt human bones, since it helped us recognize the burning conditions in which an articulated body and fleshed or partly fleshed body parts achieved complete combustion. In our first experimental approach, undertaken in an open pyre, we concluded that a whole fleshed carcass weighing around 30 kilos required approximately 700 kilos of wood to achieve complete calcination under a constantly burning open pyre which lasted for 6 hours. At the beginning of April 2023, significant experimental work involving different burning conditions was designed as part of the TEFRA project, integrating scholars from various disciplines to explore diverse archaeological issues about cremation and the use of fire in past societies. 4 experimental pyres were planned in 2 days to broaden our knowledge of the combustion of the human body through the examination of different parameters. Pigs died from natural causes were collected from local farms and used as a comparison to the human skeleton. although slight differences in the biochemical characteristics between pig and human bone certainly exist, similarities in the microstructure, body weight, diet, gut bacteria, and subcutaneous fat distribution are believed to mimic human decomposition. Except for the fleshed animals, semi-fleshed big body parts were deposited in a well-protected from scavengers open area 8 months before the experiment took place to decompose naturally. The latter were added to different areas of the pyres to record their thermal alterations compared to the fleshed carcass and the body parts. Logs and branches from olive trees were collected since the beginning of the winter, stuck to dry and used as a fuel for the pyres in order to investigate olive tree effectiveness and its thermal intensity in a cremation pyre. Contrary to our previous experiments, the entire fuel was used for the initial construction of the pyres without complementary supplementation during the burning process. The temperature of the pyres was measured using one portable infrared thermometer and 2 thermocouples set in stable points of the construction. Concerning the portable infrared thermometer, measurements were taken every 5 minutes from different areas of the pyres, following the same direction according to the anatomical position of the carcasses and the body parts. Our experimental team comprises of 3 PhD candidates from the Aristotle University of Thessaloniki employed in the TEFRA project, 1 zooarchaeologist PhD candidate in the Aristotle University of Thessaloniki, Professor Christoph Snoek of the Vrije University of Brussels, Christoph Fulop, Research Associate of the Research Center of the Humanities Institute of Archaeology in Budapest, with excellent knowledge of pyrotechnology, while many volunteers from the local community and the universities of Crete and the National Capodstrian University of Athens also participated. On Saturday, 1st of April 2023, a big open pyre was built in the village of Sokaras, located in the countryside of the Messara plain in southern Crete. The weather conditions were mild, with a mean temperature of around 18 to 20 degrees Celsius during the day. It was sunny with some clouds, and the wind in a southwest direction ranged from 25 to 28 kilometers per hour. The pyre had a rectangular bottom support ending to a pyramidal top and consisted of layers of olive trees, logs and branches of a total weight of 1 ton. Big and stable logs were put on the bottom, while thin branches with dry leaves were used on the top. A fleshed pig weighing 30 kilos was placed on the top and the center of the pyre, accompanied by various handmade vessels of different types and shapes, either empty or filled with milk, honey, olive oil, wine, fruits, and cereals. It is essential to point out that apart from the TEFRA project team, 2 archaeobotanists, PhD students from the Cyprus Archaeological Institute and the Catalan Institute of Classical Archaeology, participated in the experiments exploring issues regarding their own research questions. Freshly decomposed and articulated body parts of pig and sheep from the lower limb were put around the skull area of the fleshed pig. Burning of the cadaver started from the top, aiming from a gradual fuel combustion without human interference during the procedure. The burning episode lasted 8 hours until the complete extinguishing of the fuel and the total calcination of the skeleton. Hopefully, the pyre construction proved stable without collapse. The pyre achieved stable high temperatures reaching 1044 degrees Celsius. The whole procedure was videotaped, and the effects of fire on the skull, the trunk, and the extremities were documented in detail. After 8 hours, the pyre consisted mainly of a thick ash layer with white bones and burnt vessels, keeping many active burning areas. The pyre cooled down on its own without any artificial means, and after 36 hours it was utterly extinct, assisted by the high humidity levels during the night. The excavation of the pyre started a few days later with the great assistance of the TEFRA project team, the scientific partner Professor Diamandis Panagotopoulos of the University of Heidelberg, the research assistant Christoph Hulop, and the field archaeologist Nikos Kougoulis, after mapping the entire site and smaller areas within the pyre, adopting a grid system. Total dry sieving of the ash and soil was applied, while the archaeobotanist PhD candidate Carly Henkel from the Cyprus Institute will eventually carry out water flotation. Also, 2 earth blocks were retrieved and stored for micromorphological analysis. Moreover, meticulous 3D photogrammetry documentation of the various stages of the pyre is in progress. 2nd of April 2023, 3 small pyres were built in the town of Asimi, located in the countryside of the Messara Plain. The weather conditions were mild, with a mean temperature of around 19 to 21 degrees Celsius during the day. It was sunny with some clouds, and the wind in a south direction ranged from 15 to 18 kilometers per hour. 3 different pyres were planned to compare how the same anatomical regions of a skeleton, in various decomposition levels, react with fire until complete calcination in different burning environments. Fleshed and semi-fleshed articulated bones from the upper and the lower limb, along with freshly decomposed bones, were placed in a small open pyre, in a semi-closed furnace, and in a rectangular low-built construction of cement blocks. Concerning the open pyre, 400 kilos of wood were used, while the thermal episode lasted 6 hours and 30 minutes, reaching high temperatures exceeding 900 degrees Celsius. After the end of the burning procedure, the pyre was left intentionally uncovered to identify any potential weather effect on bones, ash and burnt soil. Regarding the artificially built constructions, 250 kilos of wood were used, while the thermal episode lasted 8 hours, reaching high temperatures exceeding 800 degrees Celsius. Insufficient air circulation due to the surrounding cement blocks contributed to slow lightning with pyre fluctuations as the procedure's beginning. Burning in restricted conditions assisted in maintaining stable high temperatures during the process without rapid fluctuations. Restricted burning conditions were also recorded in the furnace pyre, where 100 kilos of wood were used. Actual burning lasted 3 hours and 30 minutes, reaching high temperatures exceeding 800 degrees Celsius. A stable temperature of around 200 degrees Celsius was recorded inside the furnace for more than 24 hours after the end of the initial procedure. Having completed our experimental work, we can understand that experimental archaeology regarding the manipulation of the disease tends to direct more imaginative and innovative approaches. Comprehending different aspects of pyrotechnology during the cremation rituals, combined with a recording of the macroscopic heat-induced changes to the bone structure, is fundamental. It highlights the significant effect that burning can have on the body at different decomposition levels. We hope that until the next EAC, we will be able to share more advanced results concerning the heat-induced thermal, structural and chemical alterations observed on the bones derived from our experimental work, in combination with the application of analytical methods including FTIR-ATR, carbon and oxygen isotope analysis. Our ultimate aim, of course, will be to project the clues of this work to fully comprehend the use of fire by living communities on human remains in the past. Thank you very much for your attention.